today we are discussing about the very important topic or chapter, that is rotational motion. So first of all, I am saying that first of all, in rotational motion, the first topic is that rigid body here. So rigid body is defined as a system of particle in which distance between each pair of particle distance between each pair of particle remains constant. And with respect to time. Okay, it is called rigid body. Okay, means whenever the body is rotating or whenever the body is moving, then the shape and size of the body are same, that does not change. This type of body are called rigid body. Okay, so I hope so all of you understood this thing. Okay, so in this case, the second point we are discussing about that. Okay, about rigid body. So I am saying to you that a a rigid body a rigid body is one rigid body is one for which the distance between different particle of the body do not change, even though there are forces on them, means they are constant. Okay, so this type of body is called rigid body we are talking about. Okay, now the next topic is the type of motion in rigid body. Okay, we are talking about type of motion in rigid body. The next topic is type of motion of rigid body. Okay, so in this type there is a three type of motion of rigid body is. Okay, the first is pure translational motion. Second is pure rotational motion, and third is combined translational and rotational motion. These are the most important topic, and the last part will be the more important and little bit different concept rather than first and second also. Okay, so we are discussing about one by one. Okay, first of all, I am talking about pure translational body. So what is pure translational body and how we are resolving this pure translational body problem? Okay, so the first topic is pure translational body. So pure translational body is very similar to the motion in 1D. Okay, means all the forces and all the formula are similar to the motion in 1D part. So in this case, we are discussing the small part and go ahead. Okay, so a body is said to be in pure translational motion if the displacement of each particle of the system each particle of the system displacement of each particle of the system is same during during any time interval. During any time interval. During any time interval. Okay. Now, so all the such motion. Next part, all such motion, all the particle so although such a motion, okay, all the particle have same displacement, velocity and acceleration velocity and acceleration. Okay, now think a system of n particle and where the uh, let now we are discussing further. Let, okay, a system of n particle of mass m1 m2 mn undergoing pure translation, then pure translation. Suppose I am saying to you, suppose this is the body A where the mass is m1, velocity is v, going this way, mass is m2, velocity v, mass is m3, velocity v, mass m4, velocity v, and they all are going to certain body. Okay, any another body. Okay, suppose in this part they all are going to the other body. Okay, so suppose this part and the person, this part is m2, m1, m2, m3, m4. So we can say that here a1 is equal to a2 is equal to a3 and so on, an that is equal to a vector. Okay, and v1 vector, v2 vector, v3 vector, and that is vn vector, that is uh, v cap. Okay, so we are talking about from Newton's law of system. From Newton's law of system, what is F external? F external is equal to m1 a1 vector plus m2 a2 vector. So what is F external? That is capital M into a vector. Okay, where capital M is equal to sum of m1 plus m2 plus, and a vector is equal to a1 plus a2 plus. Okay, these are the two part. Understood? Now in this part, where we can see that capital M, total mass of the body, sum of all masses. Okay, so we can say that P is m1 v1 plus m2 v2 m3 v3 plus this. So P is equal to m into v vector, m into v vector. And what is m? M is equal to sum of all n. Okay, now total kinetic energy here is, kinetic energy is, that is how much? That is half m1 v1 square plus half m2 v2 square dot, and that is equal to half into capital M v का square. Okay, where again capital M is equal to m1 m2 and capital V is equal to v1 plus v2 square, like this. Okay, so these are the first part, that pure translational motion body will be covered here. Okay, now we are talking about next part, that is second part. Okay, so part 2 में we are talking about pure rotational motion. Pure rotational motion. Okay, so I am talking about, suppose I have a one part like this way. Okay, and the whole system is moving with omega, and this part will be this part, we can say that this is the axis of rotation, and this part is hinge. This is angular velocity. So I am talking about that. Suppose I am saying to you, this is the m1 mass, okay, and r1 distance, m2 mass r2 distance, m3 mass r3 distance, m4 mass r4 distance. So the whole system having more than one masses. So in this case, what happens? So I am saying to you, I can say that a motion in which every point of the body moves in a circle whose center lies on the axis of rotation, and every point move through the same angle during a particular time interval Such a motion is called pure rotation. So these are the definition of that a rotational motion. So I just little bit differentiate this, sideline this part, so that you understood. These are the definition of pure rotational motion. Okay, getting all of you. Now from here we are discussing about that how we are getting the value. Okay, so during this motion, the everything will be going as well. So we are going towards the we know that now we are talking about we know. So we are talking about we know that each each element has same angular velocity omega. So v1 is equal to that is omega r1, v2 is equal to omega r2, and so on. Okay, so vn is equal to omega rn and so on. Okay, now so here total kinetic energy is equal to half into m1 v1 square plus half m2 v2 square and so on. So here we can say that half into half is common for all of them, m1 v1 square plus m2 v2 square and so on, sum of all of this. So I can say that here I can say that we know about that v is equal to how much, omega into r. So half into m1, that is r1 square plus m2 r2 square, so on, and taken omega square at this. So this is how much kinetic energy total is equal to how much, half I omega square. This is the formula, and where I is the kinetic energy become half I omega square. Okay, okay, this is the like kinetic energy half I omega square. Okay, now here I is the moment of inertia, where I value is mr square. I is equal to mr square. Okay, this is the formula. Okay, where I is equal to m1 r1 square plus m2 r2 square and so on. Okay, these are the volume. Okay, now further the third part we are discussing here, that is combined translational and rotational motion. Okay, combined translational and rotational motion, what we are doing here. So we can say that a body is combined translational plus rotational motion if all point in the body rotates about an axis of rotation and the axis of rotation move with respect to ground. With respect to ground. Example, moving of a moving of a car tire. Both combination will be there. Okay, so this is all about today.